So, this is Rahul. In this lecture, I'm going to explain the introductions to transport layer. So, if we talk about transport layer, at which layer it comes under and TCPT model, it comes at layer 4. First one is physical data link layer and network layer. This transport layer we are talking about, right? So once we go to any layers, we will see first what are the services provided by the layer. So the services provided by the layer, first one is a process to process communication. What is mean by process to process communication? Suppose we have it computers, other side must we have also a computer, which is these two devices want to communicate to each other. What communication means? One device sends data to another device, then return back some response from that. So on each device, what we see, there are some application which are running on, right? Like Chrome, Firefox, right? Chrome or Firefox is all, or these are processes, right? What we do not call these as a software. Here we call those as a process. Suppose Chrome is a process one, and they want to the Chrome want to communicate with any process which is running on server, right? Might be jam server or some any type of process might be running on server side. In that case, what will happens, this chromes will send informations to the remote app, and then it will get back response from the uh, servers. What happens, which layers provide this kind of services? The services provided by process to process communication is transport layer, right? So second thing is addressings. We have to do addressings. What our addressings means? Suppose on this is our system, right? In our system, with there are some processes which are running. Firefox is one process, Chrome is another process, Facebook and Instagram. These are the process running on our system, right? All these process simultaneously making request to the server, right? What happens once server receive their request, and simultaneously server might in some time durations a very tiny interval server responds to the this device, right? Now suppose if these responses, there might be some numbers. Suppose if this response goes to from, and this goes to Firefox, and this goes to Chrome's, and this one. But how computer will decide which request belong to which one? Or is it, how, means another way, how servers will decide this response goes to Chrome, and this response will go to Firefox, like that. So how do we do we have any sort of numbers for each process, so that we can easily identify this response goes to this process, or this that response go to that process? Yes, we must have identity. Same questions, how does system identify the response belong to which app or which process? So answer to these questions, we use unique number to differentiate processes. What it means, so each process must have an unique numbers. Suppose Firefox has number 1, Chrome has number 2, and Facebook has number 4 or 5. In this way we can have numbers. So we'll see how these process will get numbers, but these numbers what we call port numbers. The size of port number is 16-bit. You remember it always. The port size of size of bits we use to represent a port number, which is 16 bits. So number of bits, what I told you, I range, if we take see in decimal, that goes to 65,535. I hope this is clear. So one more things, make sure that suppose I'm a person, and some I want to communicate with a guy which is somewhere, and this is the one person to whom other so the other devices also connect to, want to connect, right? If suppose this is a Google server, right? Google servers, and there is a port on any one application is running which is taking requests from all other devices and giving response, right? So if this process has unique number, right, and this number is identified by this all those devices once, do you think this numbers which this numbers to of this process will change over the period? Should it change or should it be dynamic? I don't think so. So if this process port number for this process get changed, then clients will not able to communicate very easily. So that what it means, there are some port numbers which are statics. What it means, always server side port numbers for the processes be always static. So it will make easy to communicate for clients to a server. So but in client side, the port numbers for the process might be a change with depends on the situations, right? So there are some well-known port numbers which are being used by the servers. We'll see later, but client side, what we I told you just now. So there is one authority ICANN which actually assigns some port numbers. So if port numbers belong to 1010 to 1024, then all those port numbers are assigned by ICANN authority. If it we see we uh, see this full form of this ICANN is what is International Corporation of Allocation of Name as Numbers. Name as numbers means either name or numbers. So this authority will is actually assigns some port numbers. What it doesn't mean for each process this authority will assign it. What it means, suppose this is one type of process. To this process, suppose Firefox is a one process. So Firefox, if this process is running on servers, there must be an unique numbers, right? In that way we can say it doesn't mean to Firefox at one server one has port number something, and so the server two which is running Firefox might have server port numbers for Firefox different. It should not, right? So uh, there is 1000 to 49,000 in this range. These are the registered port numbers used to avoid duplications. What duplications we will see later. Dynamics also, there are some private port numbers which are being used by users, right? These all are the in between this one, right? In this range, these are the temporary, they are dynamics, and we are available for individuals. So one more thing is, if we have port numbers, if we club with IP addresses, that we call socket address. Those who those who do programming of computer networks in C or C++, they might have used this one notations. We use colon and then write port numbers of process to which we want to communicate, right? And the third services which are flow control, serial control, and congestion control, as we have seen in case of in layer data link layers, all those services which are also provided by data link layers. But we will see this congestion controls. There are some different way we handle this problem, right? So once we move to some protocols under transport layers, we first see there are two approaches. First one is connectionless and connection oriented. What are these approaches? We'll see. First one is, suppose there is a we have communication which is a TCP communication is there, and we'll see what is full form of TCP. Suppose any process which is sending information to another device, this is PC1 and this is PC2, right? These two devices are communicating to each other. Then once it sends packet and packet reach to this device and it return by acknowledgement to this device, then these devices will know, yes, my informations or packet was delivered successfully. So this type of connections, what we call connection oriented. One more things in connection oriented is segment which are being sent by this device must have any sequence, must have sequence number 1 2 3 4 5. What it means, what it's the sequence numbers helps this device to arrange the packet in sorting order. Or one more things, there are some dependency on there are some order sequence in the 1 2 3. Suppose if 5 is reached over here, then and 2 was not reached, then this device will request to this device, please send me packet 2 and 1 and all those packets which are not received yet. So that is the main objective of writing sequence number on each packets, right? Second one is a connectionless. Connectionless is where one device is here and another device is there. So these two devices want to communicate. This device send data, but this device won't receive any acknowledgement. So this type of connections if we have, or this type of communications if there is between two devices, then we what we call this is connectionless. In connectionless we do not use any segment, oh sorry, it means any sequence numbers for any segments. Or segment means what, packets, right? So what is the disadvantage? There is no reliability. What it means, suppose there is this packet is sent to here, sent was received successfully here, but this guy will, how this guy will know? Because this guy will never know, because there is no acknowledgement. Though there is no acknowledgement, that is the reason this guy will never know. So that is mean this is unreliable transmission. The protocols comes under this connectionless communication, which is user datagrams protocols, which is UDP, and protocols comes under connection oriented, which is TCP. With and this, if this is unreliable, then this protocols is reliable one. So one more things, uh, let's see in transport later what are the protocols we have. First one is a STPC and TCP and UDP. STCP is nothing but this is a combination of these two protocols, TCP and UDP. And this just a moment before we have seen, this is connection oriented, this is unreliable, which is connectionless. There are some well-known port number you should remember. Port number 7 we use for eco protocols, for FTP we use 720. These are some, but these are very important port numbers for the services. You should remember it, and you see where the UDP protocols is not used. What it means, to establish connections we do not use when we use UDP or when we use TCP. But what we see here, we always use TCP for each communications. You have to keep remembers when we do not use UDP, right? So we'll see first protocols, which is UDP. UDP, user datagrams. So in UDP we have a headers. As we see in each packet we have two parts. First one is a data, and second one is a header part. And size of header part, if we talk about, this is 8 byte. And if we again expand this one, what we see inside in header, we have source port number, this which is 16, destination port number, size is 16. As I told you, the port numbers, the size we use, which is 16, and the total length is what, this one, total length is how much of 16 bits we use it. And the maximum size what is possible for data is, if we subtract 8 bytes, 8 byte is what, header size, then this value 2 power 16 bit we use, and we subtract this number, we get data size of data. right? Suppose we are given a question, you are given a question UDP you have, and these numbers are in hexadecimal. You can convert into a binary bit. You will see, you will get some binary stream like this, 0 1, you can convert in binaries, right? What is there first, we will have some 16 bit of these. Actually each numbers in hexadecimal is represented by 4 bits. So that is the reason, if we multiply 4 times, then we get this much number, which is 16. So 16 bits we require to represent these 4 numbers of hexadecimal. So that is the reason these 4 numbers will represent the source port, and another next ones for destination port, these numbers will represent the destination port, and next one is will tell us header plus data, what is the size, and last one is a checksum. Thank you.